Hello everyone, welcome back to my channel. My name is Piyush and this is video number 8 in the series Azure DevOps Zero to Hero. In this particular video, we'll be looking into infrastructure as a code and automating the provisioning of infrastructure with the help of Terraform and Azure DevOps. So without wasting any time further, let's have a look at the agenda. All right, so I am in my GitHub repository. You should already have the link by now. If not, you know where to find it. And I have scrolled down to the section where it says infrastructure as a code with Terraform and Azure DevOps, which is day 8. And in this demo, we'll be provisioning an Azure virtual machine. It includes Azure virtual machine, VNet, subnet, resource group, and these many resources. And to authenticate ourselves securely, we'll also create a service principal. And we also have a look at what exactly is infrastructure as a code, why do we need it, what is Terraform and how it works, the entire workflow of it. We'll create the Terraform configuration files for Azure virtual machine and all the resources that we have discussed, and we'll execute it manually from the command line, and then we'll implement the same from the Azure DevOps CI and CD pipeline. So this is the plan for today, and without wasting any time, let's head over to the demo and let's start working on it. All right, so let's start with the basic introduction of infrastructure as a code, what exactly it is. We need to understand first what challenges does it solve or why do we actually need it, right? So let's assume you are a developer or someone who's working in an IT organization and your task is to maintain servers, infrastructure, and all other services in the cloud or on premises, right? So you've been tasked to create a test environment, right? It involves a virtual machine, it involves a VPC, subnet, a load balancer, and a few other resources, right? So, what you will do in a traditional way, you will just log into the console, like whatever cloud provider you are using, you log into it and provision the infrastructure one by one, all the resources. Or you can use, like CLI commands. If it is Azure, you can use AZCLI command. If it is GCP, you can use gcloud command. If it is AWS, you can use AWS CLI commands, right? Or even scripting languages such as Bash, PowerShell, and so on. Right? So this is when there is a small environment which can be created and which can be destroyed as per the needs and requirements. What if you have to provision 50 such environments like that? How would you do it, and how much time it will take if you go down this route, or if you go down that route of scripting it? Like, what would be the complexity of it? Let's assume there were 10 resources and 50 environments, so that makes 500. So you have to provision 500 such resources by going manually, or you have to script the logic for it. It would be a tedious task, and this is not something that anyone would want to do, right? And what if you have to make any changes? Let's say you have 50 virtual machines running. What if you have to make one single change to one of these machines? How would you do it with the help of script? Or if you want to do it manually, then also it would be not advisable, right? So you need something that avoids all this mess, and automates everything. You need some sort of mechanism that takes care of your infrastructure provisioning, destruction, updates, and all the management of it. It has to be sorted, right? So that's why infrastructure as a code comes into the picture, right? It takes care of all those things, all the challenges that we have discussed, and it provides you a better way of organizing your infrastructure. So basically, instead of scripts, so you write something called as configuration files. You pass different parameters to these files, and based on those parameters, it will provision your infrastructure, make the updates to it, and it will destroy the resources if you want. Right? So it makes the management so easy and hassle free. An example of such tools are Terraform, and Pulumi. Every cloud provider also have their own set of infrastructure as a code tools, such as AWS has CloudFormation. Then Azure has two type of tools, which is ARM templates, and another one is Bicep. Bicep is a recent addition that was introduced, I guess, a couple of years back. And GCP also has deployment manager, but now GCP is also moving to Terraform. And because of the increased popularity in the market, because of how companies are adopting it and how easier it is to use and learn. So Terraform is one of the most popular tool these days in the market. So this is what we'll be focusing on, Terraform, and we'll be implementing it with the help of Azure DevOps. So let's have a look at the Terraform workflow, how it works actually. You have your Terraform core over here. You can use Terraform Cloud or even Terraform CLI. We'll be using CLI for this demo. So this is your Terraform core. And you write basically Terraform configuration files, right? Files such as main.tf, variables, output, we'll see everything, but these are a few of the files. Or you can create one single file and name it anything, but it has to be ended with the extension .tf. This is the format that Terraform supports. Just to avoid the complexity and just to make the code more manageable, it is recommended to keep the separate modules in separate files. Right? That's why we'll be using this format to divide that into multiple files. We also have some advanced concepts in Terraform, like using modules, custom modules, and a lot of other things. But we have a time constraint. We cannot learn everything about Terraform in just 1 hour or 30 minutes. So that is why we'll be covering the most important part so that you can just get started with Terraform and you can just try to use it in Azure DevOps, right? Then we have a concept of backend. There is a file.tf state, and we store that into storage account. So Azure has a storage account. This is similar to AWS S3 bucket, or if you are familiar with GCP, GCP also has a cloud storage bucket, right? So this is similar storage account within Azure itself. So you write these Terraform configuration files, and these configuration files will provision the infrastructure for you with the help of Terraform providers. Azure, AWS, OpenShift, Datadog, Kubernetes, GCP. These are one of the thousands of providers available within Terraform. So these providers are maintained by the provider itself, like AWS provider is maintained by AWS, Azure provider is maintained by Microsoft, and so on. This is not maintained by Terraform. This is maintained by their vendor company itself, right? And with the help of these providers, it provides you an interface to interact with their services, right? So let's say you have to provision some virtual machines within Azure, right? So how would Terraform interact with Azure, right? It will interact with the help of provider. So Azure RM is one of the provider. So this is how it interacts with the cloud provider to provision the infrastructure, to make the changes, and so on. Now let's have a look at the workflow. How does it work? As part of the first step, you have already created the Terraform configuration files and everything. You have created your TF state file and stored it in the backend. Now the next step is you would have to run a command called Terraform init. This init will initialize the provider, right? Here is the provider. This will initialize the provider and download the plugins and dependencies in the local directory. Right? If you are working on a Linux machine, it will download the Linux dependencies for that provider. If you are working on a Windows machine, it will download the Windows plugin and dependencies for that provider, and so on, right? So Terraform init will be the first step when you are working with it. And yes, basically, yes, you have to install the Terraform first. Without that, you cannot use it. So yes, first step is always the Terraform install, and then you initialize the infrastructure. So after you have done initializing it, the next step is to run the Terraform plan command. Terraform plan command, what it will do, it will compare your actual infrastructure with the expected infrastructure, right? So let's say you have two virtual machines already existed in a cloud, let's say in Azure. And as per your configuration, you should have three virtual machines. So it will compare these two things. It will see that yes, it should have three virtual machines, but I could only see two virtual machines. So it will provision one more virtual machine, right? So that's how it works. So it basically compares the expected and the actual results. And how it will compare? It compares that with the help of tf state file. It does not actually compares the file with the infrastructure itself. It compares the configuration file with the tf state file. Tf state file will have all the information of your existing infrastructure. So this file is really important. This is really critical. That is why we store it securely in a storage bucket, so that it cannot be accidentally deleted, or the secret information inside it will not be accidentally leaked outside. So we secure it, we make sure that versioning is enabled, and we make sure that it can be recovered if deleted, right? So this is really important file. So that's what we do as part of the next step, Terraform plan. And it will not actually make the changes. It will like show you what are the differences, like what exactly will be done when you run Terraform apply, what all changes will be made to the infrastructure. It will show you a plan. This is a dry run. This will not actually implement those changes, right? So once you have that plan, now you can select whether you want to apply those changes or not. So if you want to apply those changes, what you have to do is you have to run Terraform apply command, right? And when you run the Terraform apply command, it will then apply the infrastructure changes with the help of provider. It will provision all the resources that you want, or make the changes that you want as per the configuration files over here. And then it will also update the tf state file. Now tf state file will have the latest state of the infrastructure. Earlier, if it was 2 virtual machines over here and 3 in the configuration file, now we have 3 virtual machines over here. So it will update the same in tf state file as well. Now you see the tf state file is matching with the configuration. So when you run the Terraform apply again without any changes, it will not do anything, because the actual infrastructure is now equal to the desired infrastructure. And as soon as you make any changes in any of these files and apply the changes, it will find a difference in the tf state file and the infrastructure, and it will go ahead and make the changes. Right? So this is how it works. Now let's have a look. How does our Azure DevOps pipeline fit in this diagram, right? Why do we need it? So all the commands that were running, we were running it manually. We were running it from command line or from Terraform cloud. We were running it manually. There were a lot of manual interventions. Even though we are calling it automated provisioning of infrastructure, we still have some manual work, and we still have dependency on someone to exactly go and make the changes, right? So that's why we wrap everything, all the commands within Azure DevOps pipelines, CI/CD pipelines, and it will make the changes accordingly. So whenever you make any changes in the infrastructure in any of those files, let's say, it will detect the change with the help of the trigger that we have. And as soon as it find any change, it will trigger the steps within the pipeline, Terraform init, plan, apply, and so on. And it will make the changes automatically. So we don't need any more person to go and manually run those commands, right? Now, this is actual automation of infrastructure provisioning end to end, in which we don't need anyone to go and run the commands manually. Yes, there'll be a manual intervention, like someone will have to approve the request, or someone will have to approve the pull request, but that is the part of the process. Other than that, it is fully automated. Okay, so I hope you now have gotten some understanding of Terraform, and will get to know it more once we do the actual demonstration. So let's head over to the demo now. Okay, so as part of the first step, I'll go to my web browser and search for Azure RM Terraform, right? And go to this link, which is registry.terraform.io, and it has the Azure RM provider documentation. Go over there, and you see this is the Azure provider, and first step is to authenticate yourself to Azure. Like, there are several methods to authenticate. You can use Azure CLI command using AZ login, and then you basically enter your personal credentials and log in. But it has some issues, like when you are working for an organization, you don't really provision or manage resources by your personal ID, right? So you need a managed identity, or you need something called as a service principal, which has specific role to perform certain actions, right? So that is why we'll be using authenticating to Azure using a service principal and a client secret. You can choose any of those, but let's use this one. I'll open this in a new tab. The reason I'm showing you the documentation so that you are aware, like how do you get yourself started with it, right? So I'll scroll down, and this is basically the steps to create a service principal. It says first, if you are in China or US government cloud, you have to run this command. But if not, like first you start with AZ login. So you have to authenticate yourself as personal user before you actually create anything. So I'll go to my VS Code. I already have the AZ CLI installed in my system. So that is why the command will work for me. If you are facing any issues, please make sure you install it first. And then you can run AZ CLI commands such as AZ login. If I do AZ login, it will open the browser for me, and it will redirect me to authenticate using the Microsoft account. So I'll choose my account, and it says you have logged into Azure because the credentials were already saved in my browser. And now I can close this window and go back, and it says I'm authenticated with this particular subscription, right? And this is the tenant ID. We have the subscription ID as well. All the details are here, right? So after that, let's go back and follow the documentation. Now I can check if I'm part of multiple subscription. I can check AZ account list, but since I only have one, so it's fine. And then I can also set AZ account set subscription. Again, if we want to set a default subscription, I only have one. I don't need to run this. Then I can run this command to create a service principal with the contributor role, right? So this command will create the service principal and attach the contributor role to it so that it will have necessary permission to manage the resources that we're going to create, right? And the scope is at the subscription level. Make sure you update your subscription ID over here. So let me copy the command first, and I'll just go back. Maybe I'll open a new file, new text file. Okay, and I'll paste it over here. And my subscription ID was from the command that we ran earlier. There is a field called ID. So this is the subscription ID. Copy it and let's update it over here. Okay, now I'll copy the command and I'll just run it over here. The error that I'm getting is this: invalid schema, no connection raptors were found. So this is a git bash specific error. There is a workaround for it. So you just basically have to set this environment variable, and I will share the details again in the GitHub repository. So set this and run the command again. Okay, now it's creating, and now it's created the service principal, and these are the details like password, app ID, tenant ID. So store it somewhere safe. We will be using it later on. Let me save it over here. Okay, so now our first step is completed. We have now created the service principal. Now let's go back to the documentation, and okay, we were over here. So we have created it. It says the command will output 5 value. We have got those 5 values. Now we have to do the AZ login with the help of service principal. So let me copy this command from here. Okay, and it says these values map to the Terraform variables like so. So client ID is your app ID, and client secret is your password, and tenant ID is your tenant ID. So let me go back. I'll paste the command over here. Okay, and let's enter the client ID, which is app ID. Okay, I can just export it to a variable, but it's okay. I can just do it like this because this is a one-time thing. Okay, and then we have client secret, which is password. Okay, and then we have tenant ID, which is this one. So now let me run the command. Okay, now I am logged in with the service principal. So this is the user detail. right? Now I'm not logged in with my personal ID. Okay, let's go back. Okay, so this is what we needed to do. If we want, we can just do AZ logout as well. And now we followed this step. We authenticated ourselves to Azure with the help of service principal. Go down and let's configure the provider. You see there is a sample Terraform file. It has a virtual network, resource group, and provider, required providers, but we'll keep it separate in different files. So let's create first a file for provider. So I'll copy this, okay, and I'll go back, create a new file, call it provider.tf. Yeah, I'll set the location over here. Let's create a folder, tf code. Okay. And in fact, let me open the folder over here. tf code. Okay, let me save those so that I don't lose it. Secrets. Okay, so I have one file, provider.tf over here, right? In that, I will paste the content that we have copied from the documentation. Now it says the provider that we are using is Azure RM, Azure Resource Manager. The source is HashiCorp Azure RM. It is there in the HashiCorp repository. And the version that we are using is 3.0.0. There is this detail over here where it says skip provider registration equal to true. If you read the comment, it says this is only required when the user, service principal, or identity running Terraform lacks the permission to register the resource provider, right? But instead of that, we'll be using a service provider credentials over here. So let me delete this line, go back to the documentation and go down, scroll down a bit. Okay, after we have seen till here, and that's okay, go down. So you can export the secrets in these environment variables and that can be used, or you can place inside the Terraform configuration itself. Placing inside it in the Terraform configuration is not a good habit. So you should use Azure keyword for that or any other method. So let's use this method, which is exporting it via variables. So yeah, so we'll use this one. Okay, so I'll just copy it first. Okay, let me open this file only. I'll paste it over here and make the changes accordingly. Like we have client ID. So I'll just copy these commands and run it from our terminal window so that it will be exported in our current bash session. Okay, so I'll just run those commands. Okay, those are now exported. All right, so this is our provider.tf. Now let's go back and we were here, so we did that. Now let's copy the rest of the things like resource group, virtual network. We need actually subnets and Azure virtual machines as well. So for that, let's search it over here, virtual machine. Okay, and Azure RM virtual machine, here it is. Go down. You can copy the details from here. Let's copy it from here and we'll make the changes accordingly. And create one more file inside the same folder. Let's call it main.tf. Okay, let's paste the content over here. Okay, so the first one is a variable. We'll create a separate file for variable. So let's copy this and cut this. Let's cut this. Create a new file and call it variables.tf. Paste it over there. Save it. And let's go back to main.tf. Try to understand the format of it, right? So the first starts with resource. Resource is your resource block and then the name of resource. Name of resource is Azure RM resource group. So this format is already specified in the documentation. We have to use the same format. And this name this is the reference name through which we'll be referencing this resource internally. This is not the resource group name. This is a local name given to this resource so that we can reference that inside this configuration. I will show you how we can use it. Then this is the fields, name and location. So name is var dot prefix hyphen resources. It is appending this variable with the resources, and this variable is already defined in variables.tf. So the format will be variable block and then the name of the variable. And then we have a default value. You can leave it blank if you want, and we can specify it in another file. So let's do that. I'll just remove it from here. Okay. And let's go back. And then we also have location. So location, let's take it out from here and go back and create a variable for location as well. So variable, and name of the variable, let's give it location, right? And give it a default value. Value is Europe West, or you can choose any value that you want. Okay, let's save it and go back main.tf. Now over here we can use the reference of that variable var dot location, right? There is one more thing. This is over here, I have removed the default value. Over here I have specified it. So let me take it out from here as well, and instead create a new file. This file will call it terraform.tfvars. So any file with the extension .tfvar will be loaded as the environment variable by default. So the format in this file we can specify is as key value pair. So you provide the variable name, location, and the value. The other variable that we had was, so let's give it a prefix. Let's call it demo. Okay. So now this value will be demo hyphen resources, right? Let's go down. So this block will create a resource group. Let's go down. We have now resource Azure RM virtual network. Internal name is main, and it will be demo hyphen network. Address space is this one. Location will be Azure RM resource group. Now we are taking the location from the resource group itself. So how we are referencing the resource group? First with the resource block, Azure RM resource group, then the name of the resource group, which is .example, and then the name of the variable, which is location. So it will go to Azure RM resource group, then example, and then find location field. And then it will find the value of location from the variables, and it will assign it to this location, right? If you are following along with me and if you are trying to write this, it will be much easier to understand than just listening to it. So I would highly recommend doing the hands-on. You can pause the video and you can do the hands-on the site, right? That will be a good way to learn it. The same way, we are taking resource group name from the resource group that we have created. So Azure RM resource group .example and .name. Name is this one. Similarly, we are creating Azure RM subnet. We are creating Azure network interface, IP configuration. So we also have some more variables. Azure RM subnet, it's taking it from there. And we'll see if we are using any other variable. But for now, it is just referencing the internal variables. Then Azure RM virtual machine. This is our virtual machine with the prefix, with the name as demo-vm, and it will have location, resource group, VM size. Then we have few other details related to storage, disk. Everything is hard coded over here, but instead of that, we use variables. But I have already shown you how to use variables, so that's okay for now, right? And then we have tags environment as staging, so that's okay. So now we have created main.tf, provider.tf, terraform tfvars, and variables.tf. The other file that we have to create is backend.tf. Otherwise, what will happen is In fact, let me show you what will happen. So first, let's do a Terraform init. Let me create the alias tf equal to Terraform. So this will help us save some keystroke. Now I don't have to write Terraform every time. I can just reference it with tf alias. So let's write tf init to initialize the provider, right? So as I've mentioned, it is now initializing the provider plugins. It is finding the latest version of Azure RM, installing the Azure RM version 3.8.0. So it is initializing the backend with all the files that we have, the provider information it will get from the provider.tf file, and all other details. So it will load all the files with .tf and .tfvar extension, right? TFR extension is a separate file which is just used as to source the environment variables, right? Okay, after a few seconds, it says the initialization has been successful. Now, if you look at our code repository, it has created a folder .terraform. To expand this, it has .terraform provider Azure RM.exe because I am running this on a Windows machine. So it has downloaded the Windows based plugin for that particular provider version, right? And it also created a Terraform log file. And yeah, that's it basically. So when we run the Terraform commands, it will also create a cache inside the same Terraform folder. So make sure you put those files in git ignore, like .terraform folder, .terraform.log. So basically anything which is not with the extension .tf, you should put that in git ignore. Even tfvar files, because this is specific to your project. You don't want it to be uploaded to GitHub repository, right? So we ran the first command, Terraform init. It initialized the provider. Now let's run tf format. This will format the file if there is some indentation issues, right? It will make those changes. tf fmt. So it shows two files. That means it corrected those two files automatically. Let's clear the screen and run tf validate. This will validate if the file has, if any of these files have any syntactical errors. Let's run this. Okay, it says configuration is valid. Yeah, ideally it should not because we copied it from the provider documentation itself. Now let's run Terraform plan and see what does it show. Okay, it says insufficient feature block, at least one feature blocks are required. That means we have to go back to our provider.tf, and I guess earlier I forgot to save this provider file. That is why it downloaded the latest provider version. But now it is asking me to upgrade the provider. So we can either upgrade it using this command, or we can change the value over here to 3.8.0, 8.3.0. So anything is fine. Let me upgrade it. Okay, it will initialize the backend again, and it will download the correct version of Azure RM provider, which is 3.0.0 instead of 3.83.0, which it downloaded earlier. Okay, it did that. Now run tf plan. Okay, now let's see what does it show. It says plan 5 to add, 0 to change, 0 to destroy. That means after running Terraform apply, it will create 5 resources. It will make changes to 0 resources, and it will destroy 0 resources, right? So this is what the plan will show. That is why I called it as dry run. If you want to see which resources it will create, you can just scroll up, and you will see all the details over here. And or you can just run a simple command, this, and then pipe grep, and will be created. This string should show us what all resources will be created. So let's see. Okay, now it is showing it will create a network interface, a resource group, a subnet, virtual machine, and a virtual network. So these are all the resources that we have specified in our Terraform configuration file. Now let's go ahead. We have validated everything. Now let's go ahead, clear the screen, and run Terraform apply. Okay, hit enter. it will prompt us and it will ask us whether you want to continue or not. So we can use that option, or we can add another flag which is hyphen hyphen auto approve. It will skip that prompt. So now let's do that no over here and cancel this operation and use this command instead. Terraform apply hyphen hyphen auto approve, and this will basically skip that prompt and it will apply all the changes. Okay, so it says it is now creating the resources. It will take a couple of minutes, so I'll just pause the video. Okay, so it did not take much time and it created all the resources. It says apply complete, resource 5 added. So let's head over to our Azure portal and see if it actually did anything or not. Okay, so I'll just go to my Azure account, go to resource groups, and here is a resource group. So it is created, demo resources. Okay, and inside that resource group, there are 4 resources, one virtual network, one NIC, one VM, and one storage disk. And the 5th resource was this resource group itself. So we have all our 5 resources created inside the same location and with the same naming convention. Every configuration is same. So now if we have to make any changes, we can just make the changes in Terraform configuration and apply it, and the changes will be applied over here. Some changes are destructive in nature. For example, if I change that location of the VM in the main.tf itself, it will recreate the resource, but it will change the location eventually, but it will recreate the resource for that. So that means it was destructive in nature. Some operations, for example, if I'm just updating tags of a resource, then it does not really recreate the resource. It will just apply the changes instantly, right? So let's go back now that our resources are completed. Because we did not initialize any backend, so it created a terraform.tf state file over here, right? And if you see that, it will have a lot of details. It will have secrets, subscription ID. It will have a lot of details that we don't want to expose. Plus, we have to secure this file. We have to make sure that it is not corrupted or it is not accidentally deleted, right? Let's say if I delete this file from here, now I have lost the access to my environment from Terraform. If I delete the file and run the Terraform apply again, it will not find any resources because the Terraform state file is basically blank. It will try to create new resources, or it will do something that it is not supposed to do. Right? So it will just corrupt the environment. It will be a hassle for us to import all the resources and create the configuration again, and which is what we don't want. That is why we have to initialize it with the backend. Now let's see how do we do that. So first we have to go to Azure portal and create a new resource. Let's use the same resource group. We have to create a storage bucket. So search for Azure storage. Okay, go to storage account. So let's create a new storage account. Create. Okay, select the subscription resource group. Let me use the same resource group. Storage account name, it has to be unique. Check tutorials with Piyush 101. It cannot have hyphen, so let's just keep it this way. Okay, and region, let me select the same region, which is West Europe. Okay, select the performance. Standard is fine. I don't want any redundancy. This is just for demo. Okay, select next. Enable storage account access key. That is fine. Networking. For now, just enable it from all network, but ideally you should select this option or from a private access point. Okay, so everything looks okay. And yeah, other thing that we have to do is we have to enable the versioning for blobs, because we want to avoid any accidental deletion of our TF state file. So if we enable the versioning, it will maintain all the versions. Even if it is deleted, we can recover it from the previous version. Right? So hit review, and okay, it is still validating it. Hit create. Okay, it says deployment completed. Let's go to resource. Now we have to create a storage container inside that to host the TF state file. So go down where it says data storage. Select this option, containers, and it by default created one container. Let's create another one by clicking over here. Give it a name. Let's call it prod tf state. It did not like the underscore, so let's use hyphen, and select the access level as private. Okay, hit create. Okay, so this is our container, and this container will have our file. Now let's go over here in the browser and search for Azure RM Backend Terraform. And again, go to this link, developerhashicorp.com. It will have a sample backend configuration file. So this is what we need. Let's copy it and create a new file. Call it backend.tf. Paste it over here. Now resource group name, a resource group in which the bucket resides. So which is demo hyphen resources. We cannot use variables in this file, so that is why we have to hard code it. I'm not sure if it is a limitation or if it is as per the feature implementation, but this is what it is. Now let's put the storage account name. Storage account name, let me copy it from here. It was tech tutorials with Piyush. This one. How did I forget that? Okay, container name is prod hyphen tf state. Okay, and key is the file name that you want for tf state file, right? So let's keep it default. Let's hit save. And now let's run tf init again because we have to initialize the backend again. Hit tf init. And now it says it is initializing the backend. Earlier it just downloaded the provider details and other things. Now it is initializing. And now it says, do you want to copy existing state to the new backend? It has detected that even though we have a remote backend, but your current TF state file is in the local backend, which is in the same directory. So do you want to migrate it to a remote backend? Yes, obviously, that's why we are doing it. So hit yes. And it says successfully configured the backend and it has initialized it. Right now, let's clear the screen. And now let's see, it has created a backup of TF state, and let's see the TF state file now. You see, it is blank now because it has migrated over there and it is blank. So if we go back, and this was the container, go inside that, you see there is a file that's been created just now, prod.terraform.tf state. Now, every time I run Terraform plan or apply from here, it will remotely refer to that file instead of referring the local backend file. We don't have anything in backend. It will refer it from there and it will make the changes accordingly. So it don't have to download the file even, right? So this is the benefit of using a backend. Now we have verified everything. Everything looks good. And we have all the files created. We have an output.tf file in which we can specify if we want to output anything. So let's say if we want, after the completion of these resources, maybe just provide the name of the resource or name of the tag as an output. So in that case, we use output.tf, but it's okay for now. Let's not use it. And this is fine when we are done with our work, when we are, let's say we have done with the demo or we have done with the work for which the VM was provisioned. So we can just run tf destroy hyphen auto approve, and it will destroy all the resources created with Terraform. How it will know that what all resources were created? With the help of Terraform TF state file. So TF state file will show you that, okay, 5 resources were created from this configuration. So it will delete all those. Now it is showing, so 5 resources to destroy. This is what it is doing, and it is destroying it. Okay, so the resources have been destroyed after a couple of minutes, but I guess my bash terminal is frozen. So let me open a new terminal. Git bash. Okay, and I'll just create one more file, which is git ignore. So in the same folder, let's create .git ignore. Okay, and add these files over here because I don't want .terraform folder, and log file, tf state, there is a backup file. I don't want these files to be uploaded to the GitHub repository, including the tf-var files. So let me add that as well, star.tf-vars. And that's add this one as well, secrets.txt. Even though I will delete it after this demo, but let's just do that. Save. So now let's push it to a remote Git repository so that you can also use the repository as a sample repository if you want. Initialize the repository. Commit, first commit. Now select this. We only have one branch. Okay, let's git remote, add remote, add from GitHub. This is the GitHub. Name is origin. Okay, remote has been added. Now let's publish the branch. Says try pulling it first. So yeah, let's pull it. Pull from origin main. Yes. Try pulling first. Git pull origin main. Now let's force it with this flag. Allow merging unrelated histories. Hit enter. Okay, it's been pulled. Now we should be able to publish the branch. Okay, it says the branch has been published. Let's go back and hit refresh. So yes, our Terraform configuration is over here. I will add the details in this repo so that you'll get the idea how do we work with it. Okay, I'll update this repository URL as well wherever it is needed. Okay, so I guess you have understood the basic concepts of Terraform. How does it work? How to create the Terraform configuration file? What is the workflow and how do we run it and manage it? So now after this, we'll be implementing the same logic, the same files in Azure DevOps CI/CD pipelines. So let's head over to it. But before that, if you are getting value out of it, if you are learning something from this video, I would really appreciate if you gives it a thumbs up and subscribe the channel if you are new here. Okay, let's head over to Azure DevOps. I'm sure this diagram might look scary at the beginning at this moment, but trust me, if you have understood the concepts of Terraform and Azure DevOps CI/CD pipeline, this will be just a piece of cake for you. So let me walk you through the diagram first, and then when we implement it, then you should be able to understand the end-to-end flow. You should be able to implement it by yourself. You can follow along with me and you can pause the video whenever required, or you can do it after you understand it, whatever is convenient for you. But trust me, it will be a simple implementation if you have understood all the concepts that we have discussed till now, till this video. Okay, so let me walk you through it. So the flow is same. Developers check in the code with the help of an ID, create a pull request, it gets merged and approved in an Azure repos Git branch, and all the Terraform infrastructure file will resides in this particular repository itself. It triggers the Azure build pipeline, CI pipeline, and it has below tasks. First, it will get the source. That means it will download all the Terraform configuration files. Then it will do the Terraform install on the agent. Then it will do Terraform init again on the same agent. Then few other commands: Terraform validate, Terraform format, Terraform plan, Terraform archive. So we are not applying the changes over here. In this, we are doing till plan, and it will show you how many resources will be created, modified, or deleted, right? It will just show you the dry run. What will happen when you run Terraform apply. So it will show you all those details. And once that is done, we can just archive that file into a zip folder and then publish this archive to be consumed by the release pipeline. So this process is same what we have done so far. It's just the steps are Terraform specific steps. Once that is done, it will trigger the Azure release pipeline, which will download the artifacts first, right? And then it will trigger the first stage. The first stage is the deploy stage, right? Deploy stage, the first task of that stage would be to download the artifacts from here, right? Because these are the separate agents. So it will download the artifacts. It will extract the file. It will again run tf install, Terraform init, and Terraform apply. We are not running plan at this moment because we have already did that while the build stage. So whoever approved the release, So there could be a quality gate over here or a manual approval here. So manual approval can go and download the build or checks in the build like what resources are being changed in this particular build, and based on that, that approver can approve or reject. And once this is approved, it will trigger all these stages, and then finally Terraform apply, which will provision the Terraform resources. So resources that it has is resource group, Azure VNet, Azure virtual machine, network interface card, and then there is one subnet as well. Right? These 5 resources will be created. And it will be done with the help of a backend. So there is a backend. So there is a TF state file already stored in the backend bucket, and that it will refer. Right? Once that is done, let's say there could be multiple use cases after that or using this. Considering just one use case at this moment, once that is done, let's say this was a test environment provisioned for some testers, right, or QA team. Once they do all the changes, once they test everything out, the environment needs to be destroyed, right? Otherwise, it will just accumulate the cost. So for that, we have added one approval step before the next stage, which is destroy stage. And let's say whenever the work is completed, the approval will approve the changes, and then it will perform these steps to destroy the infrastructure, right? So whatever has been created over here will be destroyed with the help of destroy stage, and these resources will be then destroyed. So it will be a total cleanup. You don't have to manually clean up anything. That's one of the use case. The other use case would be, along with the test environment provisioning, it will have another stage to deploy the code as well, then followed by the destroy stage. And there could be many more cases. So there is no right way or wrong way of doing it. It's just based on the specific requirement and based on how it works in a particular company, you can implement it, right? Yeah, I guess we have covered everything. Now let's go ahead to the Azure DevOps portal and let's apply everything. So I'm in my Azure DevOps portal, and let's go ahead and create a new project. Let's call it Day-8, and we are doing, let's call it Terraform. Day-8 Terraform, hit create. Okay, the project is created. Let's go ahead to repos and import the repository that we have pushed to GitHub. So scroll down, click on import. Let me get the URL, GitHub. So all the URLs, everything will be there in the Day-8 folder of the repository. So do not worry about it. Okay, I have copied it. Let's go here, paste it, and then click import. Okay, this will import the Terraform configuration file. It does not have the tf-var files. So that's what we have to create. So I'll just copy it from my local directory. I guess this was the one. So let me change the location to Canada Central. I don't want it to be created in West Europe. Now, if you are worried about the Azure resources cost in this particular demonstration, do not worry about it, because you can use Azure VM, that is part of free tier. Azure Virtual Network is free, NIC is free, and then resource group is free. The storage bucket is chargeable, but if you will be done in like within an hour or two, there shouldn't be any cost associated with it. Right, so let me create a new file, call it terraform.tfvars. Okay, I'll paste the content over here and hit commit. Now let me set up the build pipeline. Go to repos and set up build. So build pipeline can be created from pipeline section itself or from here. Like if I want to create build for this repo, I can just click over here as well, set up build. It's all the services within Azure DevOps. They are tightly integrated with each other, and this is so easy to use. Okay, and let's start with starter pipeline because we'll be creating it from scratch. So let's delete it, and I will copy the first few lines from my previous project, because this is what we have been doing for now. Project was, let's Day 7, a pipeline, edit. Okay, so I will copy till here. Okay, and paste it over here. Let's add the first task. So if we go back, what we were planning to do, first we have to get the source. Okay, so that is done automatically in a CI pipeline and in the CD pipeline itself. So don't worry about it. Then go ahead with TF install. So go back and on the right side where it says show assistance, click over there and search for Terraform. If you don't find this in the search history, then I'll show you what you have to do. You just open this in a new tab, okay, and go to organization settings from here, okay, and go to extensions. So this is nothing but a marketplace extension that we are using. And okay, so I've already installed it. That is why it is visible over here. But if it's not there, what you can do is you can go over here, browse marketplace, and you can search any extension from here. Let's say if you want to use SonarQube, which we'll be using in one of the later videos. So you can search over here and get it free, and it will be installed in your organization. So this is at the organization level. If it is installed in the organization, it will be available throughout all the projects, right? Similarly, you can install Terraform extension from here, right? I have already installed it. So let's go back. Yeah. So select this task and we need to do Terraform init. So provider is Azure RM, command is init. And let's use the configuration directory as system.default working directory. We'll be using some system variables in this demo. So I will also share this with you, whatever variables we have used. So system.default working directory. Yes, so this is the default directory where an agent executes the task, right? So that's what we'll be using. So configuration directory is this. We don't need any additional arguments. Now we need to add the Azure RM backend configuration. So for that, click over here and select your subscription, right? If you have not created the service connection yet, it will ask you to authorize and create the service connection for you, which will have permission to deploy resources to provision your infrastructure in Azure, like what we have done in previous videos as well. So it will take few seconds. Okay, it's done. Then once the service connection is created, it will ask you the backend configuration. So what we can do is you go to your Azure portal, okay, go to storage account, and let's create a storage account for hosting the backend resource, right? So I will click over here, create, okay, resource group. Let's create a new resource group. Let's use the same that we have specified in the backend.tf. So I'll go back, we open this repos in a new tab. Okay, backend.tf. So our resource group name should be this. Okay, make sure the configuration matches, otherwise it will not be able to find the storage bucket. Okay, demo resources, storage account name should be this. And location, it does not have the location. So container name. Location, let's use the same one that we have used for other resources, Canada Central. Okay, Canada Central. And standard, I don't want any redundancy. Okay, that's good. Review and create. Okay, it's done. Go to resource and go down to container section over here. And then create a new container. Container name again should match with the backend bucket. So this was over there and hit create. So our container is also created. So our backend is ready. Okay, now let's go back over here. And in this step over here, let's select the resource group that we have created. Or it's not visible because we have just created it. So let me add this task again. Okay, let's search Terraform. Okay, so Terraform init, default working directory. This should be your service connection. Resource group, now it's visible. search for demo resources. This was the resource group for backend. Let's search the storage account and the container that we have created. Now the key is the name of the file. Let's take it from backend, which is prod.terraform.tfstate. So this is the name of tfstate file. Hit add. So this task has been added over here. Now we can add the display name as well. So where the task is there, let's select display name. And there is an indentation issue. So I'll go over here and hit a tab. It's fine now. So let's give it a name. And we are doing Terraform init. So let's call it tf init. Okay. Now select another task. So we have done Terraform initialization. Now the next is Terraform validate. So search Terraform again and select and validate. Let's keep the default configuration, click add. Okay, so this is added. Let's add the display name as well. So tf validate. Okay, let's add another task. The next task is tf format. So Terraform, it doesn't have it. So you can select the custom command as well. Select custom and command is fmt. Okay. Outputs to console. That's okay. Azure subscription, the same service connection. Click add. Okay. Let's add the display name and call it tf format. Let's go down. Okay. So validate, format, those are all done. Now Terraform plan. Terraform and then select plan. Okay, select the service connection, add the task, add the display name, plan. Okay, after plan, it was archive and publish. So this should be archive build, archive files. Okay. So let's change this root path from build.binaries directory to build.sources directory. Again, this will be over here. Build.sources directory is where the agent check out the source code by default. Once you do this by your own, you will get used to it. You will get to know what these directories are and why do we use it. So you will get habitual of it, and it's a good practice to use the pre-built directories so that you don't have to hard code anything in the path or in any of the variables. So this is what we'll be using over here, build.source directory, and archive type is zip. Now archive files to be created, it has to be created inside artifact staging directory. Now this directory is where all the archives will be stored by default, right? All the paths will be expanded in the logs itself, but over here we'll be using the environment variables. Okay, so this is the main directory. Then the build will be created with build.buildid.zip. So build.random number and then .zip. Right? So build ID is again an environment variable. So it will be created inside that. There'll be a zip folder with that name. Okay, so that's everything, and then hit add. So now we have added the task to archive files. Now we have archived the files. The next step is, okay, let me add the display name first. Display name, archive files. All right. The next is publish the artifacts, right? So search it over here. Publish build artifacts, this one. Okay, so path to publish, let's use the default path, artifact staging directory, and we'll customize the artifact name. So let's take this one from here. So the zip file name that was there. And then we'll also append the string build along with it. So artifact name would be, let's say 42-build or 1-build, something like that. And before that, I missed a dollar sign. So that's good. Now publish location, let's keep it default. And let me put my cursor over here, okay, and hit add. Okay, so this completes our build pipeline. Let's verify if I've covered everything. So we have get source, Terraform install, init, validate, format, plan, archive, and publish. Okay, so we have covered everything, but I guess, yeah. So if we go back in Terraform plan, we can add one more command, one more parameter to it. So let's go over here and let's see which variable we can use. We can use command options, I guess this one, and then enter this, which says -out. I'll have to put that in single inverted commas. So which says -out, build source directory, again the same directory, and create a tf plan file. So when we run Terraform plan command, it generates the output on the screen, right? These many resources will be created, modified, or deleted, all the details about it. But we can output it to a file as well so that we can reference this later. Okay, so in this build, what all resources were created or deleted or changed. That's why it's a good habit to include this Terraform plan in the build artifact itself. Yep. So everything looks good now. Let's hit save and run. Okay, let's go to this. It says the pipeline needs permission to access a resource before this can continue. So click on that and let's assign it a permission. This is basically the permission for the service connection. Okay, let's hit permit and it should trigger the build. Let's hope it does not fail. Okay, meanwhile it is doing it, let me show you the logs. So it did the checkout. Okay, then it ran tf init and it says initialize the backend. It initialized the remote backend that we used. Then it performed Terraform validate and it says configuration is valid. It did tf format and then tf plan. And if we scroll down, it will show that, okay, 5 resources to add, 0 to change, 0 to destroy. So this is what we needed. We have 5 resources in the main.tf. So you see what it did. We have 5 resources in main.tf and a tf state file was not being created because we are running it for the first time. So it compared these 5 resources with this state file and find out that we need to create these resources. Now tf state will have 5 resources and this will have 5 resources once we run Terraform apply. So tf state file makes sure that we have no discrepancy between the desired and actual state of the infrastructure, right? And then it archives the file. Let me zoom in a little bit. So this is the default artifact directory, right? Home vsts work 1a. So this is a temporary location, and then name of the zip that we have specified. It has all the files that we have used. It by default added the .git folder as well and .terraform folder as well, but you can exclude it with the help of a command within the pipeline step itself. Then publish build artifact. It publishes the build artifact and created one file from this folder artifact staging directory to a container. So this is the container name. It says 83-build. 83 is the build ID and then -build. So yeah, it publishes the artifact. Now the next is we have to create the release pipeline so that we can apply those changes. So let's head over to releases and create a new pipeline. Now select the empty job. Stage 1 is deployment. Okay, before that, let's add the artifact and sources build. This is okay. And then we have repository. Version is latest. Source alias is starts with hyphen, and this is build definition environment variable. So we have used this variable also. Click add. Okay, so let's add the trigger so that it should be released automatically. I will enable the release trigger. And let's add the default branch. It's okay. Okay, now go to deployment task. Okay, stages deployment, run on agent, and select Azure pipeline. Agent specification, let me select Ubuntu. And this step will by default download the artifacts. Okay, let's add other steps. So now again, same way, search for Terraform. First, we'll do the Terraform installation. So Terraform tool installer, this task. Okay. I guess we did not install it for build. I guess it's part of the agent itself, but it's okay. You can install it anyways. Right. So we can install the latest version over here because some agent we are using Ubuntu agent, it might have already the Terraform version installed, but if we are using some other agent, it might not have. So it's a good practice to install it beforehand. So we have this agent has already downloaded the files, the build artifact. Now we need to extract it. So let's add one more step, extract files. Okay. And let's drag it before this. Let me add the file pattern over here, which is this one. So build definition name, which is what we saw already. Then build ID 83, it was something hyphen build. So 83 hyphen build, and then there'll be a zip folder inside that. And then a destination folder. Let's use this one over here, which is system.default working direct. We'll be using this folder for most of the cases because this is where all the task runs by the agent. So file will be extracted after this. Let's add another step for Terraform init. Terraform init. So select Terraform and should be after installation. So init, change the display name Terraform init, and it will be running in the default working directory. Let's select the service connection. And these are the backend details as well. So resource group was demo resources, and then select the storage account, container, and key name was, I always forget, prod.terraform.tf state. This is the key. Okay, Terraform init is done. Now Terraform apply. We don't need to run plan now because we have already verified it. So Terraform apply, and let's change the command over here as well. Okay, and apply, in that we have to add hyphen auto approve so that it will not wait for the prompt. We are not running it in interactive mode. So hyphen auto approve, and then select the service connection. Okay, should be good. So we have extract file, installation, init, apply. Now I have saved it. Let's go back. Let's rename the pipeline first. CFCD. Okay, hit save. Okay, go back and let's add one more stage for the destruction. Right, so we can add it from here, or we can reuse the task that we have used inside it and clone this. So there'll be an option over here. So if you hover your mouse, it says clone or add. So let me clone it, added the replica of it. So let's go ahead and make the changes. Let's call it destroy stage. Okay, and go inside the tasks. Instead of apply, just change it to destroy. That's the only change we have to make. Rest steps will be the same. So change this as well, and destroy. Should be also auto approve. So let's hit save. Okay, so our pipeline is almost ready. Let's add an approval step before the destroy stage. Okay, so pre-deployment approval. Select this user. I'll assign it to myself. And it says timeout in 30 days. Let's select it for 2 days, which is more realistic timeout days. Right, and that's it. Close this and hit save. Now we have completed everything. That's what we discussed over here. We also have our backend ready. We have Plan ready, we have already executed it. Let me make a simple change in the Git repo and let it trigger end to end, right? From CI to CD. So let's go to repos. Okay, let's see what change can we make. Let's make the change in readme file. Okay, let's open this, hit edit, my first change. Okay, hit commit. Okay, now let's go to pipeline. Okay, it triggered it already. So let's go and see what it's doing in the logs. If there are no changes in the configuration file, it will not do anything. It will just, I'll show you what it will show. So if we run tf plan, it will still show 5 resources to add. But if we would have applied the resources already, it would have shown over here 0 to change, 0 to create, right? So it created another build, archived the file, and this time, let's see, let's go down, publish build artifact. The build number is 84. Okay. Build number is 84 over here. And let's see if it triggered the release pipeline as well, because release pipeline trigger was on this build. Yes, it did trigger it. You see the deployment is in progress and it failed as well. So let's have a look why it got failed. Okay, it says failed in the Terraform apply. It says the directory contains no Terraform configuration. Why is that so? Let's see. So maybe we are running it from a different directory other than where we have extracted it. So let's see. Let's see. It initialized it. That's okay. Then it downloads the artifact. Downloaded the artifact to R1A folder. Now download it and then extracting file. So the same file that it downloaded, it is extracting basically the same file. So that is also okay. And it is extracting this in this folder, which is default archive directory. And then it doesn't matter where it ran Terraform, because basically it's in the same folder. Basically it's running on the same agent. So that's okay. Then Terraform init. So Terraform init is saying that the directory has no configuration file. That means this is not running from the right directory. It says it initialize an empty directory, which it should not. So let's go to the edit pipeline again. Go to this. So it extracted correctly. Destination folder is system default working directory. Okay, I'll copy this. And Terraform init is also running in the same system.default working directory. Maybe I have to add the single colons. I'm not sure. Let's try this. I guess I figured out what the issue is. Actually, the issue is in build pipeline. So you see over here, I spent almost an hour debugging this. So you see over here, when it is archiving the files, it is archiving the folder along with it. So S is the temporary folder that it is archiving. And over here as well, it says archiving file S. So this is not right. So let's go ahead and edit the build pipeline. Let's click on edit pipeline. And we have to go down to the archive step over here and include root folder. Let's call it false. We don't want to include the root folder. Although it doesn't matter, but let's add this as well, because it's asking root folder or file. So ideally it should not treat this as a file. Okay, let's hit save and let's hope this time it is successful. Like this was already successful, but it will trigger the release pipeline as well. So let's see what does it do this time. So let me pause the video for a brief moment. Okay, this time it archived it correctly. If we see, it says found 12 files. And over here as well, it is actually adding the file instead of that folder. So this looks good. Let's go to releases. And yes, it did trigger the release. Let's go to that. And Let's go to logs. So it initialized it. It is downloading the artifact. Okay. And installing Terraform init. And now it initialized the backend. You see over here, it says initializing the backend and it found the file this time. Okay. So now it initialized the backend correctly. And if we see Terraform apply, it is applying the changes. It says 5 to add, and it is actually creating the resources if you see over here. So it will take around a minute. Let me pause the recording till then. So yes, this time it was finally completed. You see Terraform apply, made the changes. Now let's head over to our Azure portal and go to resource groups. Let's, okay, so demo RG. This was the resource group name and it has those 4 resources. 5th resource is the resource group itself. So yeah, that's what we wanted to test and that's what we were able to. Now let's do the final step, which is destroy the resources now that we have created it. So if we go back to the pipeline, it should have already triggered the destroy stage. It's just, it will not proceed further until I go and approve it because we have added the pre-deployment approval. So let's hit over here, approve. Yes, yes, destroy it and then hit approve. Okay. Now it has queued it and it has gone ahead and it will destroy the resources. Okay, let's go over here. Oh, it says 0 destroyed. Okay, so this one also failed. Like it actually did not fail. It just the Terraform, it did not find the configuration in this directory. Did we miss any step over here? So we extracted the files. Okay. In the same folder, home vsts work r1a. So this is the same folder that we have extracted the files to. And after that, we installed it, we ran init, and init also did not find. Did it take the previous build 85, and let's see what other stage took. Yeah, so it's the same build. I've compared the configuration of both the stages, and the only difference I could find is the missing single quotes and the slash sign. So let's try to add it. I'm not sure if it will make any difference, but let's do that. So over here and slash, and same for destroy as well. Okay, let's hit save. And this time I will run just this stage. So create the release and run destroy stage only. Create, go to release, logs. Looks like it is initializing the backend and it is taking few seconds. So I guess it is destroying the resources now. Yes. Okay, so if you see over here, right, it is updating the logs and it found the resources, it found the configuration files, 5 resources to destroy. So it is destroying the resources and now it will be destroyed. So I'm not worrying about it now. It should be done within 2-3 minutes or so. So yeah, that's it. I guess I've spent past 4 hours recording this video because there were a lot of issues that I had to fix. Now I'll be spending another 4-5 hours editing it, and hopefully I should be able to publish it as per our schedule. So I will see you in few hours with the video. Thank you so much for watching the video. I hope this video was somewhat helpful in understanding the concepts and you were able to implement the solution by yourself by following along this video. If you have any issues, feel free to join our Discord community and feel free to post your question or your query in the Help Azure DevOps channel and someone will help you out, including myself. And you can also post in the comment section below and I will try to reply as soon as possible. If you found any value in the video, give it a thumbs up and subscribe the channel if you are new here. And I will see you tomorrow with the next video. Take care and happy learning.